Now let's look at a graph of a function and its inverse. The point 2, 3 is on the graph of f, so without doing any calculations, what point can you tell me has to be on the graph of f inverse? Well, if you said the point 3, 2, you are correct. Remember that the inverse switches the x's and the y's. The x-coordinate on the f function becomes the y-coordinate on the inverse. The y-coordinate on the f function becomes the x-coordinate of the inverse. So find the inverse. Here's my function, f of x equals 2x minus 1. So we'll start that process like we did in the previous lesson. Change the f to y equals 2x minus 1. Switch the x and the y so that we have x equals 2y minus 1. And now we need to solve for y, get y by itself. We can add 1 to both sides. I'm going to come up here for some more room. X plus 1 equals 2y. Y needs to be by itself, so I can divide by 2. X plus 1 divided by 2 is y. Change that notation to function notation. X plus 1 over 2 is f inverse. Now we're going to graph these two functions on the axes to the right and label them. I'm going to start out with my f function 2x minus 1. So the negative 1 is where I begin on my y-axis, and I'm going to move, so f of x equals 2x minus 1. Negative 1 is where I begin. 2 over 1 is how I move, so rise over run, rise over run. So we're going up 2 and to the right 1, and we go to the right because we have positive numbers there. And we can do it in reverse, but we have to do it negative, negative. So down 2 to the left 1, down 2 to the left 1. I'm going to use a ruler just for the sake of being here and having a ruler. And this is our f of x function, 2x minus 1. Our inverse function was x plus 1 divided by 2. Now, I can rewrite this so that I have x divided by 2 plus 1 half. And I could also do, the slope-intercept form for this one, but it's a little bit trickier, and I don't really want to do that here. So I'm going to make a table instead. X plus 1 divided by 2, I want to pick x values so that when I divide by 2, I get a whole number. Well, that just means I need to pick odd x values. So negative 1, 1, 3. If I pick 0, I'm going to get 1 half. I don't want to do that. So if I plug in negative 1, x, negative 1 plus 1 is 0. 0 divided by 2 is 0. 1 plus 1 is 2. 2 divided by 2 is 1. 3 plus 1 is 4. 4 divided by 2 is 2. And I've got 3 ordered pairs here, so I can start graphing. Negative 1, 0, 1, 1, 1. Oh, I'm hitting that same graph. And 3, 2. And notice that 2, 3 was the point given at the beginning of this problem. 3, 2 is the other point. Now we can take our ruler now and connect these dots. And this is my inverse function. And then it says on number 4, draw the line y equals x on the same graph using a dashed line. Y equals x. I have a 0 intercept. There's no plus, it's plus nothing, so I'm starting at the origin. And then my slope is 1, so up 1 to the right 1, and if I go down, down 1, left 1. I'm cutting my graph here exactly in half diagonally, and I'm going to draw a dashed line here because this part of my graph that I'm creating is not part of either of the functions that I graphed, but merely a guide to show something. I want you to notice this diagonal line that's going through the middle of the graph. It splits that graph exactly in half diagonally, but also look at what happens to the function and its inverse. We have an exact mirror image across this diagonal line. So this 1, 1 point that shows up here is on the graph of both of the functions, but also for every point that I have another point on the other side at the same distance. And that's what we mean by mirrored points. the inverse function is a reflection of the original function across the line y equals x. We talked about reflections before across the axes, but the inverse is a reflection across the line y equals x. That's pretty cool. Okay, so we completed steps 3 and 4. We drew our vertical line. We've got our graph there. Finding the domain and the range. We talked about domains for linear functions before. Domain for a linear function is all real numbers. The range for a linear function is all real numbers. A linear function's inverse is also a linear function, but I do want to point out that the domain of the original function is the range of the inverse, and the range of the original function is the domain of the inverse. They switch. Here it doesn't really matter because the domain and the range are both all real numbers, but later on in this chapter we're going to be talking about a function that does not have this situation, and it will be important when we talk about domains and ranges. Now what happens if we compose a function with its inverse? I'm going to rewrite these up here. F of x is 2x minus 1. F inverse is x plus 1 over 2. So f of f inverse, we'll start with that one. F inverse is x plus 1 over 2. F is 2x minus 1. So what's inside that parentheses we'll copy over. And now we need to simplify. Well, 2 and the 2 that we're dividing by, they're going to cancel each other out. And we're left with x plus 1 minus 1 plus 1 minus 1. We're left with x. What happens if we swap the order? We do the inverse function second. So now we're talking about f inverse of f, but f is 2x minus 1. So f inverse is x plus 1 divided by 2. Inside the parentheses, 2x minus 1. We'll drop that down. Simplify the numerator. 2x minus 1 plus 1 is 2x. 2x divided by 2 is x. If we compose two functions together and we get x, these functions are inverses. We've just taken one function and undid what it did to the other function. Now we have to make sure that we've got x in here and not just a number. We want to make sure we're using the generic functions and the function expressions. But here we composed a function with its inverse and we got x each time. The function and its inverse cancel each other out. We can take a look at an application. Here we have a table that lists the percentage of college freshmen with a high school grade average of A or A minus during a particular year. They want you to start out by evaluating P of 1970 and interpreting the results. Well, 1970 here, P of 1970 would be 20. So for A, we would say P of 1970 is 20. Remember, the table is listing the percentage of college freshmen with a high school grade average of A or A minus. So the percentage of college freshmen with a high school GPA of A or A minus in 1970 was 20%. We can make a table for the inverse function. What makes this really nice is if we already have a table for our original function, to create a table for our inverse is so easy. We just switch the columns or the rows. In this case, we're going to switch the rows. So a table for P inverse will have x and P inverse x. And up here, x was the years, so P inverse will be the years. P of x was the grade average, so x is going to be the grade average. And that's B. Make a table. And part C says evaluate P inverse of 43. So P inverse 43. 43 here. 43 here for x. P inverse of 43 is going to be 2,000. And if we were interpreting this, 43% of freshmen had a grade point average of A or A minus in the year 2000. The point being, when we're given a table or when we create a table, to create the inverse table, we just switch those columns or switch those rows.